Okay, about mesh analysis, again the same thing as nodal analysis. We will have the same approach. Just to inform you guys, I'm recording the session again. We transform the circuit into phasor domain or frequency domain. We apply circuit laws in frequency domain, which is as the same as in time domain. Then once we have the answers, we transform back to time domain. So just like we did for nodal analysis, we apply mesh analysis. We find the meshes or the loops in which there's some current rotation, and we know that from KVL that the sum of all the voltages around a loop is 0. So we take the loop loop equations to model the circuit, and then we solve it. Okay, so we assign mesh currents I1, I2, and so on. We apply KVL to each of the end meshes and use Ohm's law to express the voltages. Previously we used Ohm's law to express the currents. Now we have the voltages. Just to confuse things up a bit, for nodal analysis we write node voltages in terms of currents. In mesh analysis, we write mesh voltages in terms of voltages. Then solving the equations as usual. So let's consider this particular circuit, example 3. Determine current I0. We are looking for this particular current I0 going upwards. So normally in a question, these currents are not mentioned. We have to identify the mesh currents, but which is not very difficult. Anyways, let's say this is I1, this is I2, and this is I3. And we have two sources. One of them is a current source, one of them is a voltage source. And this circuit is already converted in phasor domain. How do we know that? Because this is phasor and this is also phasor, and also these are also in ohms in terms of impedances, right? All right, so we proceed. We start writing the equations of the mesh. Let me bring my pen again. Just see what's. Okay. So we know that there are 3 loops here. This one. By the way, we know that we come to that, but I0 is actually equal to negative of I2. We'll come to that. So at mesh 1 or around mesh 1, which is this one, we can write the equation. We can write that it is 8 I1 plus J10 I1 minus I3 plus minus J2 I1 minus I2 equal to 0. Just for those who want a refresher, if we're considering node the loop 1, we consider loop 1's current as the dominant one. That's why I put I1 minus I3 and I1 minus I2. When we are in I2, we will take I2 minus I1, and when we are in I3, we'll take I3 minus I1 or whatever, right? At mesh 2 will be 20 angle 90 minus J2, see I2 minus I1 minus J2 I2 minus I3 for the capacitor here, plus 4 I2 equal to 0, right? I hope you guys are following. And similarly at mesh 3 will be okay. Luckily at mesh 3 we can see, okay, again the mistake that you guys can make is write the equation at mesh. Okay, I'm writing a wrong equation. Okay, minus J2 I3 minus I2 for this capacitor, then plus J10 what is it, I3 minus I1 plus 5 angle 0 equal to 0. What is the mistake here? Anyone?
Current source.
Current source. Okay, yeah, wonderful. Uh, if there is a current source in a mesh, there is a current source in a mesh, then actually we sort of know that particular current because current and series are same. So if this is I3 and this is the current source, this means I3 is equal to, so we don't have to write equation in which there is a current source. Okay, simply I3 is 5 angle 0 amperes, which we can replace here and here. Any question? All right, so this is uh, the proper typed equations. Again, the same thing, it's nothing different. All right, you can see that I3 here is 5 and we found, so one of the equation is this one. We should have simplified form. Yeah, this is the first equation and this is the second equation, I believe. So again, solving it, first equation, second equation in matrix form, just to do one more time with you guys. 8 plus J8 and J2 for I2, J2 for I1 and 4 minus J4 for I2, I1, I2 equal J50 minus, it should minus J30, minus J30. We have the matrix form, the determinant of the system matrix, they call it, is 8 plus J8, J2, J2, 4 minus J4, and I have it comes out to be 68. Similarly, if we are looking for, suppose, delta 2, because we're interested in I naught, which is actually negative of I2. So we just need to find I2 in this one. So delta 2 would be, we replace the second column with this. So 8 plus J8, J2 and J50 minus J30, which will be equal to 416 angle minus 35.22. Okay, I believe that you can solve these calculations, right? Is it okay? So delta 2 is 416.17, should be 0.17, angle minus 35.22, and V2 would be V2 or I2? I2, sorry. I2 would be delta 2 upon delta, like 416.17 angle minus 35.22 divided by delta is 68 and I2 is 6.12 angle minus 35.22. I naught is basically negative of I2. When we say negative of I2, we subtract from 180. So it will be 6.12 and subtract from 180 would be 144.78 amperes. So this is the solution. The main thing is that we are applying mesh analysis. This is nothing new, except we have complex numbers. This is all the calculation in proper form, because my handwriting is very beautiful. Okay, let's consider this circuit now. Oh, this is the exercise 2, by the way. This is exercise 2. So this will be, we'll be doing it in tutorials with you guys. All right, example 4, we have this circuit. Again, do we notice something new in this circuit, guys, that we can make mistake? Can anyone?
There are two current sources. One is between two meshes.
Oh, yes. So we have a problem of having, first of all, like, okay, you're right. So if we start making, suppose currents, this is one current, this is another, this is another, and this is another. So this one here is actually simplifying our work, that we, if suppose this is I1, I2, I3, and I4, the value of I4 is the negative of this current. Is that okay? This is, I think everybody would appreciate. But if we start writing the equation, let me again be the devil's advocate and be the devil to write the equation for mesh 1 minus J4 I1 minus 4 angle 0 plus 8 I1 minus I2. Okay, the mistake here is that I'm putting a current instead of a voltage. It has to be voltage, and because of this I am writing a wrong equation. All right, so this is what we call super mesh. We have a current source between two loops. We have to consider this as a super mesh. What is a super mesh? A super mesh results when two meshes have a dependent or independent current source in common, as shown in the previous one. So how do we solve it? We create a super mesh by excluding the current source and any elements connected in series with it. So if I go back, even if there was a resistor here, we would be removing this completely. We just making it completely open circuit like this. So the current source in the super mesh is not completely ignored. It provides the constraint equation necessary to solve for the mesh currents. Okay, once again, it looks like complication, but it's simplifying our solution because we get one equation very easily without writing the impedances. And I didn't mention it last time. We call it the constraint equation. Okay, so for this circuit, this is the super mesh. Okay, I did some animation. It's not appearing here now. Yeah, okay, this one. So this is the super mesh, which I will replace this mesh 3 and 4, I1, I2, I3, and I4. So I'm naming them again, I1, I2, I3, I4. I2 we already know it's minus 3. By the way, it was actually 3 angle 0, right? But 3 angle 0 is actually the real part is 3 and the imaginary part is 0, so it's just 3. We can write 3 only. Just recall from complex numbers. We have this current source in between these two meshes. So we completely remove this branch and we consider this as our new mesh, right? Is that clear? Let me show you again. This was the current source in between two meshes. We have completely removed this branch to make this as the super mesh. And if you just take a look one more time, we can see that we have an equation coming from this particular branch, which will be, if we say is I4 and this is I3, we can say that I4 is in agreement with 4 ampere. So I4 minus I3 equal to 4. Very simple equation. Remember, we are writing current equations. In the voltages in the form of currents, we have one equation very easily. All right. I4 equal I3 plus I3 plus 4. So for mesh 1, we get minus 10 plus 8 I1. What is the current in this particular thing is I3. So I1 minus I3 minus J2 I1 minus I2 equal to 0. This is one equation. And we already know that I2 is minus 3. So minus 10 plus 8 I1 minus I3 minus J2 I1 minus of minus 3 equal to 0, because since I2 is minus 3. All right. So in yeah, this is the equation. Yeah. So right now we have I1, I2, I3 as the unknowns, but I2 can be replaced with minus 3. So we have simplified, and we just have I1 and I3 as unknowns, or maybe I4 later on. We can replace it. I2 is minus 3 from the super mesh. Yeah, we didn't write the equation of super mesh. Yes, we have to write the equation for the super mesh as well. So let's start from here. The current here is I4, which will be 6 I4 plus J5 I4 minus I2. We can replace it with minus 3 plus 8 I3 minus I1 minus J4 I3 equal to 0. At the end, I'm a bit messy, so please forgive me. Minus J4 I3 equal to 0, which is written in very clean, very nice form here, right? We already know that I4 equal to I3 plus I4, so we can remove I2 with a minus 3, this one, and I4 in terms of I3 plus I4, so we get this simplified equation. You can see that the terms have been replaced. Do you want to take a look at it? Maybe I give you 10 seconds if you get the same value here. Any question? If anyone has a question, please raise your hand. All right, I assume that is okay so far. All right, so now standard. We have two equations, two unknowns I1 and I3. We put them in matrix form. I'm not doing it right now because it's now a repetition of what we have done. We get the determinant. We find delta 1, because what were we looking for? We always forget. The question is to find, I think V0, is it? find V0. For V0 we need I1 and I2. We already have I2, so we do not need I2. We just need to find V1. That's why we are solving for just I1. So delta 1 is this, and I1 will be delta 1 upon delta. This one, the required voltage V0 is minus J2, which was the component there, and the currents in between, we put the currents, we simplify it, we get the V0 voltage. Any question, guys? So once again, I stopped the recording here as we have so we have done nodal analysis, we have done mesh analysis, including the super node and super mesh. So I am stopping this recording. All right.